Today we are explaining the paper Rethinking on Policy Distillation of Large Language Models Phenomenology, Mechanism, and Recipe.
What is the main question they are trying to answer?
They ask why on policy distillation sometimes works brilliantly and sometimes fails, even when the teacher looks stronger on benchmarks.
Before the results, what exactly is OPD in this setup?
Here the student generates a rollout first. Then the loss matches the student to the teacher on those student-visited prefixage with reverse scale.
So success depends on what the teacher looks like along the student's own trajectory, right?
Exactly. The paper says the conditions matter. The teacher needs a compatible thinking pattern. And it also needs knowledge the student has not already absorbed from the same training pipeline. Let us start with the compatibility evidence.
What should I compare first in this part?
Compare the early overlap on the right with the downstream accuracy on the left. The teacher whose token choices already line up better with the student gives better distillation, even though the raw teacher benchmarks are broadly comparable.
Why is a bigger or higher scoring teacher still not enough?
Because size only helps if it adds behavior the student can actually reach and copy. When two teachers come from the same pipeline, the larger one may still look almost the same from the student's local point of view.
What makes this comparison evidence for new knowledge instead of just more parameters?
In both model families, the teachers that received extra A or L post-training transfer much more than same pipeline teachers. The gap recovery rate also rises. It is the extra capability added by post-training. Now the paper runs a reverse distillation test to make that point harder to dismiss.
Why is this reverse direction so convincing?
Because both same family teachers drag the student back toward its B or L behavior, including the larger one that scores higher. That means the student sees nearly the same local target distribution from both teachers on the states it visits. So extra size alone does not create transferable signal.
Once OPD is succeeding, what training signals reveal that?
The paper tracks overlap ratio, overlap token advantage, and entropy gap. In good ones, overlap rises, the advantage gap closes towards 0, and the student's uncertainty profile gets closer to the teacher's. Here is the clearest mechanism plot.
What pattern separates the good teacher from the failing one?
The successful teacher keeps pushing overlap upward while the entropy gap stays smaller, and that tracks stronger benchmark accuracy. The failing teacher stalls early, so the student never settles onto the teacher's high probability region.
Do they need the whole vocabulary to get that effect?
Not really. A small shared token set already carries most of the probability mass. And the paper shows that optimizing only those overlap tokens is enough to match the full objective surprisingly well. From there the paper turns to a practical recipe for failing runs.
How does this rescue strategy actually help?
The cold start uses teacher rollouts to move the student closer before OPD begins. So the initial overlap is higher and the final ceiling is better too. The paper pairs that with teacher-aligned prompt selection, which sharpens shared token alignment. But it also warns that too much prompt alignment can lower student entropy. So mixing in outside prompts is safer.
Does the paper see any limit to OPD, even after these fixes?
Yes. Dense token level reward is not a free lunch. Reward quality degrades with trajectory depth. Later tokens become less reliable. And that is why the paper treats long horizon distillation as an open limitation rather than a solved problem.
So the whole story is compatibility, new capability, then careful control of the local token signal.
Exactly. This paper turns OPD from a mysterious recipe into a testable picture of when transfer works, why it works, and how to recover it when it breaks. That wraps up this paper walkthrough.